So now we're going to discuss lines that are parallel and perpendicular. We're going to start off with the equation of the line we had in our last example. And what I want to find is a line that's passing through a given point and that's parallel and to that line, and the equation of a line that's actually passing through that same point and perpendicular to that line. So let's write this down. Okay. So parallel lines, first of all, what do they share in common? Okay, well, it's kind of obvious to see that for the same increase in x, there's the same increase in y. So if you increase x by 1, in both cases, you're going to go up by the same amount. So that means that they have the same slope. Same slopes. For perpendicular lines, okay, this is a result actually from Sec 4, so I'm not going to re-explain it, but it's possible to show with not too much work that the product of the two slopes, so let's say this is M1 and M2, their products are going to be -1. So in other words, if you've got a given slope, the other slope is the negative of the reciprocal of the previous slope. So we're going to use these two principles here to get the equation of our line. So maybe we call that M1 and M2, but they're the same here. So in the first case, parallel lines, well, we know that if they are parallel, the slope is going to be the same as the slope of the previous line, which was what, 7/2, right? Because that's what multiplies x. And then we've got a point, 2, 3, so we're done, right? Y minus the y coordinate is 7/2, so the slope times x minus the x coordinate. We use the point slope form, it's way faster. In this case, well, what's our slope here? It's going to be the negative of the reciprocal of the previous slope. So the reciprocal of 7/2 is going to be 2/7. Essentially, you flip the numbers. So I've got a slope, I've got a point, I'm done. 1 minus 3 is minus 2/7 x minus 2. So those are pretty easy questions to answer. Okay. There's another form for a line, right? So there's point slope form, slope intercept form. There's also something called the standard form. Standard form. What's the standard form? Standard form is when x and y are on the same side of the equality. So either you write it like that, or sometimes the c is on the other side. So it could also be like this. So those I would call them both in standard form. And I'm just going to show you how you can write down the equation of a line in standard form. So let's say you've got a linear equation and you want to convert that into standard form. So the question would be convert to standard form. So essentially you want to have your y's and your x on the same side. The first thing you'd probably do is expand this. Okay, collect like terms. Okay, and then you just send x and y on the same side. So we'll subtract 2y. So that could be your answer. Maybe in the book, and I think in the book they focus more on this, so they would send probably the 8 on the other side. Okay, but to me they're both good. So this is okay, standard form. And finally we're going to finish with horizontal and vertical lines, which are lines that are perpendicular, right? Horizontal lines perpendicular to a vertical line. So if I look at an horizontal line, it would be something like this. One thing I can see is that if you go forward by 1, you don't go up. So that means what? That your slope is 0 here. Okay, for a change of x, y is not changing. Okay, so in other words, if you would calculate delta y over delta x, for any delta x that you choose, any change in x, y is not changing. So it's 0 over some positive number, it's definitely going to be 0. Okay, so that's why it's 0. For a vertical line, it's like this. So here the problem is that you're not change. X does not change. It stays the same here. Okay. So your slope, if you try to calculate it, y would change, right? Along the y changes, but x is never changing. The change in x is essentially 0, and you can't divide something by 0. So there's no slope here for these lines. Okay. And we can see this by writing down the equation of a line of such a line. So imagine that this is 2, 3. This would have the same x, right? Because since it's vertical, there's no change in x. Let's say 2, 7. The equation of the line would be any point which satisfies x equals 2. So any point which has 2 for its x coordinates. So that would be the equation of that line. Okay. So in general, it would be x equals some constant. Let's say some constant k. And for a horizontal line, it's the other way around. So you could have, let's say, 1, 5, and 3. But 5 is not going to change because you stay along at the same altitude, essentially. So the equation here would be all points where y is 5. So in general, horizontal lines are of the form y equals to a constant, k. And vertical lines, x equals to a constant, k. One has a slope of 0, the other has no slope.